So hello everybody, my name's James. I work at IBM and a developer advocate working in our cloud division. And today I'm going to talk to you about kind of building more intelligent bots, right? Bots that you can kind of speak to with natural language, that can kind of understand the user intent and then can respond with dialogue as well. You know, we know that bots as a technology area has exploded in 2016, right? We had this whole track at the conference about building bots. But I think you've seen people like Facebook launch their messenger platform for bots. You've just heard about Slack bots. You've got Microsoft with their bot framework. But I think if you look at a lot of those toolkits and those libraries, what they're focused on, right, is the integration or the plumbing side of it, right? How do you define some web endpoint that passes some JSON back and forth to your bot service? And I think what they often ignore or don't help you with is the much harder aspect, which is now you're going to be writing systems that interact with users using natural language, right? How do you understand what users want you to do? Natural language processing, is very, very hard. People have PhDs in this entire subject. And I'm just a lowly JavaScript developer, right? So how can I build bots that can interface with natural language using things like the IBM Watson APIs to do all the hard work for us? Now, 5 years ago, IBM kind of announced to the world a system that was adept at this very task, at kind of natural language processing called IBM Watson. It was heralded as a kind of step forward in AI systems. And IBM built this system to try and compete on a game show called Jeopardy! Jeopardy is a kind of American quiz show where the host posts questions in natural language against a kind of variety of topics. And you have the contestants, the humans, have to kind of compete against each other and bet money and try and answer. And IBM tried to build a computer system that could do this. And it competed live on television over 3 episodes against the best Jeopardy players in the world, Ken Jennings and Brad Rutter, who are the kind of people on the slides here. And over 3 episodes, Watson won comprehensively. It was faster, it was more accurate, it could give you questions and answer much quicker, and it kind of won comprehensively. And this task of answering natural language questions offline about a variety of topics was something that computer systems had found very difficult to do before, and as I said, was heralded as this kind of next generation AI system. And in 2011, when this happened, this is what Watson looked like. This was the one Watson system that lived at the Thomas Watson Research Laboratories, which is in upstate New York, and it was a combination of a high-performance computer that had been kind of built for the show with some custom software that they developed during the project. And a couple of years ago, when I was at the lab, I was at the T.J. Watson labs in upstate New York, I got to go to the machine room and I kind of met Watson, right? I saw the machine that had been used to run the system. But that was 2011, right? And it's 2016. And today, Watson is available as a series of APIs on our cloud platform that you can integrate into your application and access using a really, really simple RESTful interface, which means that even me, right, the lowly JavaScript developer, can add things like text-to-speech, like natural language processing, like visual recognition, into your application as if it's just another framework or web API, right? I don't need to go back to college and get my PhD in natural language processing. But what kind of practical examples could you do with this technology thinking about bots? Well, let's think about it this evening, right? Hopefully my talk goes really, really well in the next 20 minutes, and I'm hanging out in San Francisco and I want to relax and go and see a film. But I don't live in the Bay Area, so I'm not really sure what's out or what's good at the moment. So I have to go and do some research on the internet, right? So I might go to IMDb or Fandango and try and find a film, right? Try and find a comedy. And if I put in comedy into IMDb, it's going to give me back 71,292 titles that it knows about. And this is really helping me find a film that's out tonight, right? And I could fiddle with all the UI controls and the checkboxes and the radio buttons to be able to drill down my search query, but I don't think that's a very nice user interface. So what I would probably do is, and what I'm sure most of you would do is you might ask a friend, right? I have friends that live in the Bay Area, so we can have a really short, directed conversation using natural language about this use case, and they can really quickly and efficiently recommend me a film. Right? I'm asking my friend Bernie S. here. And so we can have this really short, directed conversation. So the question is, right, why can't I have this kind of interface to IMDb via some kind of bot? Right? IMDb knows about all of the movies that are out there. Why can't I use natural language to generate a search query rather than kind of messing around with checkboxes and radio buttons? And so we did this. It's called a conversational agent. We built it with open source. It's available on GitHub. and we used, obviously, the IMDb APIs and just some of the off-the-shelf services to allow you to be able to do this. And I can kind of show you this now. So I'm going to swap back to the desk mic. And if you go to the link here, if you go to the link here, you can play with this yourself after. You can actually use it to get real recommendations. So let me mirror my screen. There we go, right, and then go to full screen. So let's see if I can find myself a movie for tonight. So I can say, hello, James, says hello. I can say, what can you do? And it says, okay, I can look at your movies that are available now by genre or rating and show me trailers. Okay, I can't search by actors or anything like that. You think, okay, that's fine, that's not too much of a problem. So I can say, can you find me a comedy? And it's going to say, when do you want to go and see that film? I say, I'd like to go tonight. And it's going to ask me what kind of rating I want to see. Now, as a Brit, right, I don't understand your weird American rating, so I need to ask Watson to clarify. So I can say, what is R? And it'll kind of recognize, or it's not what does R mean? And it can tell me this is a kind of an adult movie, right, restricted, and that's the kind of comedy I want to see. So I could say, restricted will be fine. And it should go away and it query the IMDb APIs, passing out, obviously, the bits of the query that it knows about, and use that to make me recommendations, right? So there's 23 films of R-rated comedies that are available at the moment, and I can say, what about Neighbours 2? Right, and it will give me the trailer and it will give me some blurb to be able to look at that. And Watson does not think this is a good idea, right? He thinks this is a bad movie, but I'm a Zac Efron fan, so I'm going to go and see this. I'm going to go and see this anyway. So I need to know where to go. So I could ask, where is the movie theatre? And Watson will say, did you mean showtimes? Yes, I do. And so it's going to ask me for a location, and then use that to give me a link to Fandango to go and book my tickets for Bad Neighbours 2 at a local cinema. And based on a really, really short bit of kind of directed conversation, I've been able to go back to Keynote. I've been able to find out, right? I've been able to find out the answers to my query really, really easily. So as I said, using their kind of off-the-shelf Watts APIs, we can create systems like this really, really easily. And I could dive into the technology now and kind of walk you through the code and show how little there is. It's mostly just plumbing integration. But I want to tell you how to kind of build kind of intelligent bots like this. And rather than starting with the solutions, I want to think about, I think, the challenges that you have to overcome to kind of have interfaces using natural language. And the first is this issue, I think, of how do you script these kind of natural language conversations? How do you build bots that can kind of generate natural language? If we think about the movie bot example, what we want to know from the user is what kind of film do you want to go and see? What's the rating? Where do you want to go and see it? When do you want to go and see it? But if we're using natural language as our interface, we don't really have control over the order that information comes in, right? Someone could come to our bot and say, find me a comedy for my children tomorrow, and I'm in London, and we have all that information up front. Or they could just say, hey, Watson, can you recommend me a movie? And the bot should be able to kind of enter into dialogue to tease out those bits of information which we need to be able to kind of run the query against the IMDb APIs. The system needs to be respond appropriately using natural language. And so we can do this using what they call the IBM Watson Dialogue Service. And what this service allows you to do is kind of generate a model of a conversation and then pass that to the Watson system so that passing the user input in from the user, it can generate the appropriate response on your behalf. It allows you to train a kind of decision tree for natural language, for dialogue, that it can then use to generate those responses on your behalf by kind of, you define the conversation paths that you kind of enter into with your bot. You identify kind of entities or variables that you want to capture from the conversation, and then you invoke the APIs to be able to help you with that. Now, to be able to kind of model your conversation really kind of efficiently and effectively, it builds on something called conversational analysis. Conversational analysis was a linguistic framework developed in the 1670s by this kind of groovy-looking chap here called Harvey Sachs. And he was a sociologist working in Los Angeles, and his research was focused on looking at conversations and trying to develop a model of them, right? Looking at all conversations and saying what are the common elements, what are the constituent parts, and and he came up with this framework called conversation analysis, which is very efficient at kind of modeling and mapping kind of natural language and natural language dialogues. And the Watson service actually uses this and uses entities from this linguistic framework to allow you to actually build up your own models. And the way it does this is you use a markup. So you use markup to actually model your conversation. You can see some here in the background. It's called XML that we all recognize. And we have nodes and elements and entities from conversation analysis to be able to craft this XML file, which defines all your conversation paths and input grammars that you want to match. And then you can pass that to the service and then call passing in user input and get that to decide what the response to be. So because this talk is kind of very, very short, I'm not going to spend my time showing you how to create the model because that would take kind of hours and hours, but I want to show you how you would use that once you've actually defined it, what you can do with it, what it looks like, and then we'll actually show you some of the limitations and how you can go beyond simple keyword matching. So let me jump back now and then do that. Yeah, that's better. So if I find Chrome, so this is the open source project for MovieBot, right? So it's available on GitHub. You can go and pull it down. It's written in Node.js and kind of play with it and kind of look through the code, understand how it works, and kind of use it as a basis for other intelligent bots. And if you're kind of digging through the source code, you'll come across the training folder, which contains our kind of conversation markup in the file, and this is it. It's called this XML file. And you can see here it's got all the kind of the different kind of conversation pattern input grammars that I'm not really going to go into too much detail about. But once you've done this, once you've defined your model using the XML, you can use something called the dialog tool. And the dialog tool is kind of like your development editor for working with the dialog service. It allows you to upload bits of dialog, create models, and then you can use the text box at the bottom to kind of interact with it and check it's working correctly. So I could come in here, I could click to add my new model, and upload the dialog XML to start to be able to interact with it. Because time is very, very short in this talk, I've actually already uploaded it, and it's called MovieBot. And you can see I can interact in kind of development mode at the bottom and check that it's working. So I can say, can you find me a comedy for my children? And what you'll notice is that as I'm kind of interacting with the dialog service, under the covers, this kind of web page is just sending API requests to the REST API. And we have this thing on the right-hand side called a profile that's being filled in. And this is where when Watson extracts entities and concepts as part of your conversation, it gets stored so that you can reference them. So you can see, for example, it's picked up that I'm interested in the topic movies. It's picked up the genre is comedy. And it's also referenced, because I've said I want it for my children, right? The rating is automatically inferred that it's going to be G, it's going to be kind of suitable for children. And using the Watson dialog service API, you can pull this profile information out at any time, and that's how we would extract the information and then use that to call the IMDb APIs. So what if I was to say kind of a slightly different query, right? If I kind of say, never mind, who was the main actor in the Hunger Games? You can see Watson's identified. Now I'm asking about actors and giving me a response telling me it can't look at movies by actor. But what if I ask a slightly different query, which means the same thing, right? So who was the main or the lead role in the Hunger Games? So it's the same query, but I know this is a bit of a trick, right? Because I know this conversation model doesn't actually know about the concept or core roles, and it falls back to its kind of default response that you can code into the model. And that kind of leads me on to my next issue, which is, let me do that. My next issue, which is, how do you go beyond kind of simple keyword matching like this? What you might have gathered there is the dialog service on its own, I wouldn't say is particularly intelligent. It relies on you as a developer to develop an effective conversation model to map all the kind of user inputs that people might use and the conversation paths that you want to be able to use to develop dialogue. And it gives you some tools to be able to help with this, right? It has wildcard matching on the input grammars to make it a bit easier. It allows you to define synonyms so that they automatically get expanded in your model as well. But the dialog service on its own isn't a particularly kind of cognitive. And what you'll find is actually for many, many use cases, you can go really far with just this service, right? For very simple, directed, kind of predictable conversations, often you only need this service, but it doesn't often scale when you want to get into kind of more broad scenarios where you're getting into more free-form conversation, where you want to go beyond simple keyword matching to understand user intent. And to do that, we want to be able to add some of the kind of more intelligent Watson NLP services. So for example, we might want to use something called a natural language classifier. And this is a service that allows you to, using NLP algorithms, kind of classify sentences or classify text into a set of kind of pre-specified categories. So in the movie app example, right, when people are talking to the bot, we need to understand, are they asking, check me show times, are they asking to find films, are they asking who's the actor, you know, to search for movies on IMDb. And rather than having to kind of define all the input grammars to match keywords to understand what they're asking, we can just train a classifier to do this automatically, and that's what they actually did to enhance the demo. So for example, what they found is that they trained a classifier with 1,300 examples, some of which you can see on the screen, for different bits of dialogue that the user would interact with through the bot. And there was 11 different kind of categories or classes of dialogue or user intent that they wanted to predict. So by training a classifier based on historical examples, they could then use this classifier in the bot to kind of predict with confidence what users were asking about for kind of future interactions. When you're using the natural language classifier service, you kind of go through this iterative development model where you prepare your test data, right, which is a list of examples of the classes that they should be assigned to. You train a classifier, you then test it with new data, and it gives you back confidences for the test data, and you can validate things like the precision and the accuracy and to see if it's working correctly. And then you go back to your training data and you update it with things that's wrong, and then you kind of train your classifier until you get your classifier to be accurate enough to be able to use in production. Now, the natural language classifier service works best with classifying short sentences. So think fewer than 60 words, for example. It doesn't really work classifying whole documents or whole paragraphs together. It understands more languages than just English. So I think like French and Spanish are in there, and it can understand those, and the NLP algorithms work. The number of kind of categories that you can classify is limited to a couple of hundred, but that's more than most people need. And as I said, you go through this kind of iterative development process to train the classifier, check it's working, and then you can use that to categorize future dialogue coming in. So how do we kind of integrate the natural language classifier into the dialogue service to allow it to kind of handle those scenarios rather than us having to kind of explicitly define all these input grammars? Well, this is the architecture of our bot before we integrated the natural language classifier service, right? We were using the bot to handle gathering the user input. We were passing it to the dialogue service where we created our model, when we were using the dialogue service to respond, and it was using the manual input grammars that we defined to do kind of keyword matching to understand user intent. But now what we're going to do is we're going to pass our text through the classifier before we pass the dialogue to the dialogue service, and it's going to give us back a set of confidence values of kind of percentages, how accurate it thinks the user intent is to all of those classes which we've trained it on. Now remember, when we were using the kind of dialogue tool, as we were conversing with the bot, the profile in the right hand side was being updated with all of the kind of entities that have been extracted from the dialogue that we could query. But using the dialogue APIs, you can update that profile yourself with any information you want. And what we do is, before we call the dialogue service, we update the user's profile with the current set of classification values. And in the model itself, we then can do things like branching and conditional checks to use those values to decide on the response rather than using the input grammars we defined. And we can actually use this pattern of using the base dialogue service to model your kind of conversation, and then adding the extra services in by kind of adding those values into the profile to allow us to add in much more kind of complicated and make much more intelligent bots. So for example, I could add in something like tone analysis. And what tone analysis does, it's a service in the Watson catalog that allows you to classify the sentiment for documents based on a load of kind of psychological characteristics. So, you know, is the text in the natural language, is it anger, is it fear, is it happy, is it sad? and again gives you back confidences for the sentiment based on those categories. Now imagine I could develop a bot, or I could enhance MovieBot to detect when my user's getting really angry. Because if a user's using language that indicates they're really angry with the bot, maybe the bot's not understanding them very well. And then we can branch to a kind of response, a default response to say, hey, maybe you'd like to call our customer service representative, or hey, can we start your video chat? Because it sounds like the bot is not kind of satisfying your user need, and is giving you a bad user experience. And we can use this pattern with any of the Watson services and the base dialogue service to add in kind of more intelligent things. So I kind of started off this talk saying that building bots was easy, right? We had all these toolkits and these languages and these frameworks to kind of help you do this. And I think what they're focused on is often the integration side of it, right? How do you define some endpoint to call some web service that passes some JSON back and forth? And this is really easy to do now, right? Even me, the lowly JavaScript developer, can kind of take care of this. But the hard thing, which I think a lot of these toolkits don't help so much with, is natural language processing. Right now, we're building systems that interface with our users using natural language, and that is going to be our interface. So we need to be able to simulate real dialogue. We need to be able to understand user intent automatically and respond accordingly. And we want to go beyond simple keyword matching when we're building bots. And so to do this, we can use services like the IBM Watson APIs that kind of give you a nice, simple RESTful interface to do complex things like natural language processing and visual recognition and speech to text, and are aimed at developers who don't have kind of PhDs in just those subjects. And we looked at how we can develop bots using the kind of the base dialogue service. So for example, we can use that to generate our conversation model, and we can get really far with just this approach, right, with simple kind of input grammars. But when we want to go beyond that, we can add services like natural language classifier or tone analysis and update the profile with those variables to allow us to control the conversation. So if you want to kind of build bots that go beyond simple keyword matching, that understand what your users say and can respond accordingly, you can now use services like the IBM Watson APIs that mean that you don't have to kind of go back to school and get your PhD in natural language processing. So thank you very much. If you've got any questions, I think I'll be outside afterwards. You can come and grab me. If you want any of the references to this talk, all the source code, all the slides, and all the other material, go to the bit.ly link at the bottom, and I'm on Twitter if you've got any questions afterwards. So thank you for listening, and I'll be outside for questions after.